Hello and welcome to Algebra 1, Lesson 6. In this video, we're going to learn about solving linear equations with fractions or decimals. So up to this point, we really haven't worked a lot with equations that have fractions or decimals. And I kind of did that to keep it very simple in the beginning. But as you kind of progress through your chapter on solving linear equations in one variable, you're going to see a lot of problems with fractions and decimals. So when they occur, we can use a special trick to get rid of them. So let's first talk about how to solve a linear equation with fractions. Now, a lot of people hate fractions. So when they occur inside of an equation, and you're just starting to learn equations, it makes it that much worse, right? You're already struggling to figure out how to solve an equation, and now I'm throwing fractions in there, and you're like, oh, what am I going to do? When you first start out the problem, you're going to clear your fractions by multiplying both sides of the equation by the LCD. Remember, that's called the least common denominator of all fractions in the equation. So, for example, we have 7/4 x plus 1/2 x equals 63 over 20. What you'll do is look at all your fractions. So here's a fraction, here's a fraction, here's a fraction. Okay. I want you to look at the denominators of each fraction. So you have a 4, you have a 2, and you have a 20. So 4, 2, and 20. Those are my denominators. And we want the LCD. Remember, the LCD is equal to the LCM, the least common multiple of the denominators. So what is the LCM of 4, 2, and 20? Well, remember from pre-algebra, the way we figure this out, we would factor each number. So 4 would be 2 times 2. 2 is a prime number, that's not going to factor. And 20 is going to be 5 times 4. 4 is 2 times 2. Very, very easy to do. And to build the LCM, we take each prime number from each prime factorization and we throw it in there. The only thing is that you have to remember, if a prime factor is repeated, so in other words, in 4, we have 2 factors of 2. In 2, we just have that number. And in 20, we have 2 factors of 2. I put the largest number of repeats between all of the prime factorizations. So with the number 2, it occurs twice at most, right? It occurs twice here. It occurs twice here. So I'm going to put 2 in when I build my LCM. And if that doesn't make any sense to you, go back to the pre-algebra lesson on finding the least common multiple, and it will make sense to you then. All right, now the next thing I want to put in here, I have a 2 and a 2. I have a 2 here, a 2 and a 2 here. I only have a 5 left to put in. So throw in a 5, and 2 times 2 is 4. 4 times 5 is 20. So the LCM for 4, 2, and 20 is 20. So that means my least common denominator here is 20. Now, once I have figured that out, all I do is multiply both sides of the equation by that, and the fractions will go away. So I'll have 20 times 7/4 x plus 1/2 x equals 63 over 20 times 20. Now, remember, this is legal because of the multiplication property of equality. I can multiply both sides of an equation by the same non-zero number and preserve the solution. So on the right, it's pretty easy. This just cancels with this, and I just get the number 63. On the left, I've got to use my distributive property, and I've got to distribute 20 to each term here. So I'm going to end up with 20 times 7/4 x. So 20 times 7/4 x plus 20 times 1/2 x. Now, you can look and see, okay, between 20 and 7/4, this is going to cancel with this and give me 5. 5 times 7 is 35, so I'm going to have 35x plus, and then over here, this is going to cancel with this and give me a 10. 10 times 1 is just still 10, then times x, so I'm going to have 10x there. This equals 63, and we'll scroll down a little bit more. So now I have an equation that's clear of fractions, and the solution is going to be the same as if I had just worked with the fractions. So I would start out by just combining like terms. 35x plus 10x is 45x, and this equals 63. Now to get x by itself, I divide both sides of the equation by the coefficient of x, which is 45. This will cancel with this and just give me an x. And 63 over 45, that's not going to be a whole number. So I just have to reduce the fraction. So 63 is 9 times 7. 45 is 9 times 5. So the greatest common factor there is going to be 9. I can cancel this with this, and I'll have 7/5. Right? So x equals 7/5. You're going to get a lot of fractional solutions moving forward. I kind of stayed away from it in the beginning because I wanted to make everything nice and easy for you to understand before we start really ramping it up and dealing with fractions and decimals. All right, so I want to do two things. I want to check this. So let's erase everything here. And we're going to go back up to the top. So remember, x equals 7/5. So I'm going to plug a 7/5 in everywhere I see an x. So 7/4 times 7/5 plus 1/2 times 7/5 equals 63 over 20. All right. So over here, nothing I can cross cancel. So 7 times 7 is 49. And 4 times 5 is 20. Plus, over here, nothing I can cross cancel. 1 times 7 is 7. Over 2 times 5, that's 10. Now, in order to add, I've got to have a common denominator. So I'm going to go ahead and just multiply this by 2 over 2. And this will be 14 over 20. 14 over 20. And this equals 63 over 20. And of course, the left and the right side are going to be equal. 49 plus 14 is 63. This is over 20. And this is equal to 63 over 20. So our solution, x equals 7/5, is correct. One thing I want to show you, if we would have just left the fractions as is and just work with them, you're going to get the same answer. So clearing the fractions is just more of a trick that you can use if you just don't like working with fractions. Sometimes it just makes it a lot easier, right? Nice and simple. So let's say I have 7/4 x plus 1/2 x equals 63 over 20. If I want to, I can combine like terms here to simplify on the left. So move this kind of x over to the side and get a common denominator. Multiply this by 2 over 2. So then I'll have 7/4. Let me scroll down here. I'll have 7/4 x plus 1 times 2 is 2. So 2 times 2 is 4. So 2/4 x equals 63 over 20. So to combine like terms here, I'm just going to add the numerator. 7 plus 2 is 9. So I would have 9. The common denominator is 4. So 9/4 then times x equals 63 over 20. Now, how do I isolate the variable here? We talked about in one of our beginning lessons, if I have a fractional coefficient for x, and I want x by itself. Remember, if I multiply a number by its reciprocal, the result is 1. So if I multiply 9/4 by 4/9, remember the reciprocal is found by taking the denominator and putting it into the numerator, taking the numerator and putting it into the denominator, I'm going to get 1, right, if I multiply these two. So this, that all cancels. So this is 1x. Now, because I do it over here, I've got to do it over here. So this cancels with this and gives me 7. This cancels with this and gives me 5. So what am I going to have? I'm going to have x equals 7/5. And that's exactly what we got by clearing the fractions. Now, in this particular case, because I'm very good at working with fractions, right? I've been doing it a long time. It didn't take me any longer to work this problem with the fractions involved. For yourself, you might not be that good with fractions. So you might want to just take the time and clear the fractions so that you don't have the added stress of trying to solve an equation and trying to work with the fractions together. Now, when we get to decimals, because most of you work with calculators, you might not want to clear it. It might not save you any time. It just depends. All right, let's take a look at another one. So we have 3/2 x plus 1 plus 4/3 x equals negative 31/8 plus 2/3 x. All right, so what I'm going to do is, again, clear the fractions from the equation. So let's look at our denominators. We have a 2, a 3, an 8, and a 3. Now, I'm looking for the LCD, the least common denominator, and the way I find that, I want the least common multiple of the denominators. So 2, 3, and 8. And I'm not going to put 3 in twice, right? It's the same number. So 2 doesn't factor, so I'm just going to throw that in there. 3 doesn't factor. Just going to throw that in there. And 8 is 3 factors of 2. So how many factors of 2 am I going to put in when I'm building my LCM? Only 3, right? So I'm going to put 1 and then 2 because I already have one over here from when I did this. Remember, when you build your LCM, you want the largest number of repeats between any of the prime factorizations. So between 8, you have 1, 2, 3, and 2, you have 1. The largest number of repeats is 3, so 3 goes in when you build this. Okay, so we have 2 times 3, which is 6, times 2, which is 12, times 2 again, which is 24. So that's going to be my LCM for those numbers. And so my least common denominator is 24. All right. So LCD is equal to 24. And so I multiply 24 by both sides of the equation. So I'm going to put some brackets here. Very important that you use brackets or parentheses because you need to distribute, okay? You need to distribute this value of 24 to each term. I see a lot of students will just write 24 next to this, and then they multiply by that, and then they're done. You need to multiply 24 by every term to make this legal. Okay, so over here, negative 31/8 plus 2/3 x. And we'll enclose this inside some brackets as well. And then we'll use our distributive property. So what I'm going to do, I'm going to multiply 24 by 3/2 x. So 24 times 3/2 x. And as I do it, I'm just going to do the calculation, kind of save some time. So 24 would cancel with 2 and give me 12. 12 times 3 is 36. So this would be 36x. This is 36x. Okay, plus. Next, I'd have 24 times 1. That's very simple. That's just 24. Then plus. Next, I'd have 24 times 4/3 x. So 24 times 4/3 x. The 24 would cancel with the 3 and give me an 8. 8 times 4 is 32. So this would be 32x. 32x. And then this equals, I'm going to do the same thing over here. So 24 times negative 31/8. So negative 31/8 times 24. This cancels with this and gives me a 3. 3 times negative 31 is negative 93. So negative 93. And then I have one more, 24 times 2/3 x. So that's going to be plus 2/3 x times 24. And this 24 would cancel with this 3 and give me an 8. 8 times 2x is 16x. So this would be 16x. Okay, so now we're free of fractions. Now, I just go about my usual business, which is to simplify the left and the right side. So this over here, 36x and 32x, we can combine like terms. That's going to give us 68x. So 68x plus 24 equals. Over here, I really can't do anything. I just have negative 93 plus 16x. Now, as we learned in previous lessons, we've got to get the variable terms on one side of the equation. I have 16x over here, and I have 68x over here. So I need to move one of them. I always move the one on the right to the left. I like my variable to end up on the left. So I'm going to move this over here. And the way I'm going to do that, I'm just going to subtract 16x from both sides of the equation. That'll go away. And then minus 16x over here. 68 minus 16 is 52. So this would be 52x plus 24 equals negative 93. All right, so now I want to get the variable term by itself. And to get this by itself, I need to subtract away 24, right? Because I have plus 24 over here that's next to the 52x. So minus 24 minus 24. So that's going to go away. The left side is now just 52x. And on the right side, if I have negative 93 minus another 24, I'm going to end up with negative 117. All right, the final step here is to isolate the variable completely. And if I look at it, I have what? I have 52 times x. So to get x by itself, I divide by 52. I divide by that coefficient of x. All right, so divide both sides of the equation by 52. This will cancel with this and give me 1. 1 times x is just x. So that's going to be equal to negative 117 divided by 52. So this won't result in an integer or whole number. So we're just going to reduce the fraction. So negative 117, I'm going to write negative 1 times 13 times 3 times 3. And for 52, I'm going to write 13 times 2 times 2. So what can I cancel? What can I cancel? I can cancel this 13 with this 13, and I'm really left with what? I'm left with negative 1 times 3 times 3, or negative 9, over 2 times 2, or 4. So my answer here is going to be that x equals negative 9/4. X equals negative 9/4. So I'm going to plug in a negative 9/4 everywhere I see an x. So I'm going to have 3 halves times negative 9/4 plus 1 plus 4/3 times negative 9/4 is equal to negative 31/8 plus 2/3 times negative 9/4. All right. So if we have 3 halves times negative 9/4, what can we cancel? Well, nothing. So we just have to do the multiplication. 3 times negative 9 is negative 27. 2 times 4 is 8. So then plus 1 plus, over here, this 4 would cancel with this 4, and I'd have negative 9/3. So negative 9/3, and equals, we have negative 31/8 plus, over here I can cancel before I multiply. Negative 9 divided by 3 would be negative 3, so this cancels with this and gives me a 3. And this will cancel with this and give me a 2 down here. So this completely canceled out. That's just a 1 now. So we'd have basically just negative 3 halves. So plus negative 3 halves. All right, so on the left, I got to think about getting a common denominator. So 8 is going to factor into 3 factors of 2. 3 is not going to factor. So the best I can do there for my LCD is going to be 24, right? 8 times 3. So negative 27 over 8 times 3 over 3. Plus, for 1, I'm just going to write it as 24 over 24. It's the same thing as 1. And then plus, we'll have negative 9 over 3 times 8 over 8. Put this equal to negative 31/8 plus negative 3 halves. All right. So what is negative 27 times 3? Well, that's negative 81. So this would be negative 81 over 24 plus 24 over 24 plus negative 9 times 8 is negative 72 over 24. Let's go ahead and figure this out real quick. So if I have negative 81 plus negative 72, so 81 plus 72, kind of mentally, 1 plus 2 is 3, 8 plus 7 is 15. So that'd be 153 attached to the negative. So that's negative 153 plus 24. And we can kind of do that in our head also, because really, you think about 153 minus 24, that's going to give you 129, and then just slap the negative on there. So we would have negative 129 over 24. So this is equal to, and then over here, really I can easily see that the LCD is going to be 8. So I just need to multiply this side by 4 over 4, and I'd have negative 31/8 plus negative 3 times 4 is negative 12 over 2 times 4 is 8. So negative 31 plus negative 12 is going to be negative 43. So we'll have equals negative 43/8. So a lot of you at this point will stop and go, okay, I got the wrong answer. What happened? Always make sure that when you get fractions, they're reduced to their lowest terms or they're simplified. These fractions are the same. The one on the left is just not simplified. If I think about negative 129, I can write this as negative 1 times 43 times 3. I can write 24 as 8 times 3. And we can see that we can cancel this 3 with this 3. And I'm left with negative 1 times 43, or negative 43, over 8. That's what I have over here, negative 43 over 8. And you can't simplify that any further, right, on either side. It doesn't matter because you got the same number on either side. But if you wanted to think, okay, well, can I simplify this further just for the sake of completeness? You can't, right, because 8 is 2 times 2 times 2, and negative 43 is not divisible by 2. So you'll end up with negative 43/8 equals negative 43/8. And so you know your solution, which we found was x equals negative 9/4, is correct. All right, let's take a look at another type of problem you're going to come across. So we have 37/18 plus 2/3 x equals negative 1 plus 2/3 times this quantity, negative 4/3 x plus 9/4. If I begin my problem the normal way, if I say, okay, what's the LCD of all the fractions involved? and I go to multiply it, it's not going to clear all the fractions right away. What you need to do is use your distributive property first. So if you come across a problem where you have fractions that are inside of a set of parentheses or a set of brackets, use the distributive property first and simplify. So what I want to do, so I have 37/18 over here, plus 2/3 x equals -1 plus, I'm going to remove the brackets. 2/3 times -4/3 x. I would have 2/3 times -4/3 x. So 2 times -4 is -8. 3 times 3 is 9. So this would be -8/9. So I'm going to put minus 8/9 times x. And then again, 2/3 times 9/4. So 2/3 times 9/4. And what I can go ahead and do is cancel this with this. That'll give me a 3. Cancel this with this, and that'll give me a 2. So this is canceled completely. It's just a 1. And so I'll have 3 halves there. So this will be plus 3 halves. Okay. So once you've done that, go ahead and think about, okay, what's the LCD now? So I have 18, I have 3, I have 9, and I have 2. And at this point in your math career, you should be able to kind of look at that and say, okay, I know the LCD is 18, right? So I know most of you can do that. If you can't, again, take the steps. So LCM of 2, 3, 9, and 18. So I know that 2 doesn't factor. I know that 3 doesn't factor. 9 is 3 times 3. So I'm only going to put one more copy of 3 in there because 9 is 3 times 3. I only want the largest number of repeats to go in. 18 is 2, which I already have in there, times 3, which is already in there, times 3 again. You could think about it as 2 times 9 or, 3 times 6. However you want to do it, it's going to break down into 2 times 3 times 3. And we already have that there. So if we multiply, we get 18. So that's the LCM of those numbers. And so for the LCD, it's 18. All right. So now we're just going to multiply both sides of the equation by 18. Again, you want to use brackets or parentheses. Make sure that you multiply each term by 18. All right. So over here on the left, if I do 18 times 37/18, we know that 18 would cancel with 18, right? So this would just be 37. Then plus, we have 18 times 2/3 x. 18 would cancel with 3, giving me a 6. 6 times 2 is 12. So this would be 12x. And this equals, over here, 18 times -1 is -18. Over here, 18 times -8/9. Think about 18 canceling with 9 and giving me a 2. 2 times -8 is -16. So this would be -16 times that variable x. Then plus, lastly, I have 18 times 3 halves. 18 would cancel with 2 and give me a 9. 9 times 3 is 27. Okay. Now we just simplify. So I can't do anything to the left. I'm just going to copy that down. So 12x plus 37. I'm just going to reverse the order. On the right, I can simplify because I can add -18 and 27. That's going to give me positive 9. So I'd have -16x plus 9. I want all my variable terms on one side of the equation. So because I have one there and one here, I always like my variable on the left. I'm going to move that guy over there. So I'm going to add 16x to both sides of the equation. So that's going to go away. 12x plus 16x is 28x. So plus 37 equals 9. I'm going to get my variable term by itself on the left. So that means I'm going to be subtracting away the 37 from both sides of the equation. So that's gone. So I'll have 28x equals, what is 9 minus 37? That's going to be -28. And we divide both sides of the equation by 28, the coefficient of x, in order to isolate the variable completely. And I'm going to have x is equal to -1. Okay, x is equal to -1. All right. So we could erase all this and check. So x, again, equals -1. So we'd have 37/18 plus 2 times -1, which is just -2. So I'm just going to write -2/3. And this is equal to negative 1 plus 2/3 times this quantity, we'll have negative 4 times negative 1, so that's positive 4, over 3 plus 9/4. So on the left side, I just multiply this by 6 over 6, and I'll have a common denominator, right? So I'd have 37 minus 2 times 6 is 12, over the common denominator of 18. 37 minus 12 is 25. So this would be 25 over 18. 25 over 18. And 25 is 5 times 5. 18 we know is 2 times 3 times 3. So really we can't make that any more simple. Over here, if I think about 4/3 plus 9/4, I'd multiply this by 4 over 4. I'd multiply this by 3 over 3. And so negative 1 plus 2/3 times 4 times 4 is 16 over 12 plus 9 times 3 is 27 over 12. And 16 plus 27 would be 43. So I'd have 43/12. So let me just erase this and write 43/12. So if I'm multiplying here, this is going to cancel with this and give me a 6. And so what I'm going to have is negative 1 plus, I'll have 1 times 43 or 43 over 3 times 6 or 18. So to get a common denominator here, I'm going to write this negative 1 as negative 18 over 18. So we just need to think about what is 43 minus 18? Well, that's 25, right? So this becomes 25/18, just like on the left side of the equation. And so we know that our solution x equals negative 1 is correct. So let's talk a little bit about when your equation has decimals in it. In most cases, you're using calculators on your exams or your homework, and working with decimals when you have a calculator is not any more difficult. So this is just something I'm teaching as a matter of completeness, because you do need to know how to do it, because you might be asked for it on a test, but I don't think it would actually save you any time, especially if you're working with a calculator. But if you're faced with decimals, I just want you to think back to when we learned that if you multiply by 10, or 10 raised to a whole number that is 1 or larger, we're going to move our decimal point one place to the right for every 0 in our power of 10. So, for example, let's say I have the number 6 and I multiply by 100. Well, I have 2 zeros in this power of 10, and so I take 6, I write a decimal point after 6, because you can always write 6 as 6.0. And then I can move the decimal point 2 places to the right to get my answer, because I have 2 zeros in that power of 10. So this is really 600, right? We know that 6 times 100 is 600. We also could write 100 as 10 to the second power. And kind of the shortcut is to look at the exponent there and say, okay, I have 2 places that I'm going to move my decimal point to the right. Because if you have a 10 raised to the power of 2, it's going to be a 1 followed by 2 zeros. And once you get good at this, you can be very, very quick with these calculations. So let's say I had 3 times 10 to the 4th power. I see that there's a 4 here as my exponent. That means that I would have a 1 followed by 4 zeros, right? That's what 10 to the 4th is. So this would be a 3. Put my decimal point down, and I'm going to move that decimal point 4 places to the right, because there's a 4 there. So 1, 2, 3, 4. And I'm going to end up with 30,000, right? Because 10 to the 4th power, 10 to the 4th power, again, is a 1 followed by 4 zeros. So 1, 2, 3, 4, or 10,000. And you can kind of mentally see that 3 times 10,000 is 30,000. It's pretty easy to do. So if we do this and we involve, kind of some decimals, we can kind of use the same principle to clear the decimals. So if we have 6.32, and I want to make this into a whole number, meaning I don't want to see this decimal point anymore, I have 1, 2 decimal places here. All I need to do is multiply it by a number that has a 1 followed by 2 zeros, right? So I'd multiply it by 100, or 10 squared. So times 100, so this would be equal to 632, right? Because this would go 1, 2 places to the right. So essentially what's going to end up happening is we're going to look at our equation, and we're going to see the largest number of decimal places between everything involved. So we're then going to multiply both sides of the equation by a power of 10 that will clear that decimal. So you want to clear the largest number of decimal places. So if the largest number of decimal places you have is 3, then you're going to multiply by 1,000, right? It's a power of 10 that has a 1 followed by 3 zeros. And if you clear the one that has the largest number of decimal places, you're going to clear all of them. All right, so let's take a look at 20.01 equals negative 6.7 minus 10.7n minus 8.6. I'm going to look through this equation. I have 2 decimal places here. I have 1 decimal place here, 1 here, and 1 here. So the largest number of decimal places between any of these numbers involved would be 2. Now, in order to clear the equation of decimals, I need to multiply by a power of 10 that will allow me to move all the decimal points in the equation 2 places to the right. So to do that, you're going to multiply by 100. Okay, just think about, okay, I need 2 zeros in the power of 10, so that's 10 squared or 100. So again, I'm going to use parentheses or brackets to put 100 outside. 20.01 equals, I'm going to have a 100 outside of here too. Negative 6.7 minus 10.7n minus 8.6. Very, very easy. Now we're just going to use our distributive property. So 100 times 20.01. Again, move your decimal point 2 places to the right. So this would be 2001. This is equal to, over here, 100 times negative 6.7. You'll have negative, you'll have 6. This is going to go 1. So I'll have a 7, and then 1 more place to the right, and so a 0. So negative 670. And then minus, here we have 10.7n. So I'm going to have 10. This is going to go 1 place to the right. That's going to be a 7. 1 more place to the right. That's going to be a 0. And then my n. So that's minus 1070n. And then minus, here we have 8.6. So that's going to be 860. Right? This is going to go 2 places to the right. So it's going to go right here and then right there. So we have a transformed equation now that doesn't have any decimals involved. And again, you just go through after you have this and do your regular procedure. So I would combine like terms here on the right. Negative 670 minus 860 is negative 1,530. So this will be negative 1,070n and then minus 1,530. And this is equal to, over here on the left, we have 2001. So I still want to isolate my variable term. And to do that, I'm going to add 1,530 to both sides of the equation. And so 2001 plus 1,530 is 3,531. And this equals negative 1,070 n. All right, now to get n by itself, I just divide both sides of the equation by the coefficient. So divide by negative 1,070, divide by negative 1,070, and this will cancel with this. And then 3,531 divided by negative 1,070 is going to give me negative 3.3. So I get negative 3.3 equals n. Now, notice how I wrote it like that versus as a fraction. You can do either. Because we're working with decimals, I chose to write this as a decimal. You can do either one. It does not matter. So I'm going to rewrite this as n equals negative 3.3. And we're going to go back up to the top and check it. Okay, so we're going to have n equals negative 3.3 here. So we're going to have 20.01 is equal to negative 6.7 minus 10.7 times, again, negative 3.3 minus 8.6. Okay, so over here on the left, 20.01 is not going to change. Don't need to do anything there. On the right, I need to do my multiplication first. What is negative 10.7 times negative 3.3? It's going to give me 35.31. 35.31. Okay, so now I have negative 6.7 plus 35.31 minus 8.6. So I'm going to add my numbers with like signs first. What is negative 6.7 minus 8.6? That's going to be negative 15.3. So I'm going to write this as 20.01 equals negative 15.3 plus 35.31. And now we just need to add over here. What is negative 15.3 plus 35.31? That's going to give me 20.01. So 20.01 equals 20.01. Same number on the left and the right. So n equals negative 3.3 is the correct solution. All right, let's take a look at another one. We have 17.8321 plus 2.589y equals 0.8 times the quantity y plus 4.37 plus 4.6y. Now, just like we saw with fractions, when you're trying to clear decimals, you've got to use your distributive property first if you have decimals inside the parentheses. So 17.8321 plus 2.589y equals, distribute this inside here, so 0.8 times y is 0.8y, and then distribute this inside here, so plus, so 0.8 times 4.37 is 3.496, so 3.496 plus 4.6y. So now I'm going to look to see what number has the highest number of decimal places. I have 1, 2, 3, 4 here. I have 1, 2, 3 here. I have 1 here, 1, 2, 3 here, and I have 1 here. So the highest number of decimal places is 4. So that means I need to multiply by a number that has a 1 followed by 4 zeros. So I'm going to multiply both sides of this equation by a 1 followed by 1, 2, 3, 4 zeros, or the number 10,000. So I'm going to have 10,000 times 17.8321 plus 2.589y. And again, make sure to put this inside of parentheses. You're really multiplying 10,000 by each of these numbers. You can't make the mistake of just multiplying it by 17.8321. It's also got to be multiplied by 2.589y as well. Okay, so over here, I'm going to have 10,000 also multiplied by, and I'm going to need to put this off the screen for a minute. So we'll have 0.8y plus 3.496 plus 4.6y. Again, inside of parentheses. Okay. So starting over here on the left, if I multiply 10,000 times 17.8321, it's going to be 178,321, right? This will go 4 places to the right. And so I end up with 178,321. So then plus, now if I multiply 10,000 by 2.589y, I'm basically going to have 2589 and then a 0 at the end. Again, this goes 4 places to the right. And so it would pass the 9 and then go 1 more, right? So that's why I have this 0 here. It would go 1, 2, 3, 4 places to the right. So that ends up giving me 25,890 and then times the variable y. And then over here on the right, I have 10,000 times 0.8y. So if I have 0.8, and this goes 4 places to the right, it's going to go 1, 2, 3, 4. So that's going to be 8,000. Then again, times the variable y. Then plus, over here I have 3.496. So this is going to go 4 places to the right, so it's going to pass the 6 by 1 more place. So I'm going to need to write 34960, right? This is going to go 1, 2, 3, 4 places to the right. And then plus, we have 4.6y. So 10,000 times 4.6, we think about 46 here. And I'm going to need to put 3 more zeros. 1, 2, 3. This is going to go 1, 2, 3, 4 places to the right. And then don't forget the y. And then we have our transformed equation. Unfortunately, it's so big it doesn't fit on the screen. But we go through the same process. On the left, I can't simplify anymore. So I'm just going to write 178,321 plus 25,890y. This is equal to, over here on the right, I can combine like terms, and I need to put a comma in there. I have 8,000y plus 46,000y. That's going to give me 54,000y. Then plus, and I put a comma in here, 34,960. So again, I want all my variable terms on one side of the equation. And so I like my variable term to be on the left. I like my number to be on the right. So I'm going to go ahead and subtract 54,000y from both sides of the equation. That's going to go away. And just to save a little time, I'm going to simultaneously subtract 178,321 from both sides of the equation. So why am I doing that? Well, what's going to end up happening is I'm going to have a variable term on this side. This is gone, and I'm just going to have a number on the right side. All right, so what is 25,890 minus 54,000? That's going to be negative 28,110, and then y. And this is equal to, what is 34,960 minus 178,321? That's going to give me negative 143,321 361. And now as a final step, we just get y by itself. We divide both sides of the equation by negative 28,110, right? The coefficient of y. So negative 28,110. So negative 143,361 divided by negative 28,110 is 5.1. So I'm going to have y equals 5.1. Now let's erase everything and we're going to check it. So again, y equals 5.1. So I'm going to have 17.8321 plus 2.589 times 5.1 equals 0.8 times the quantity. For y, I'm putting in 5.1 plus 4.37 plus 4.6 times 5.1. So starting on the left, 5.1 times 2.589 is 13.2039. So I'd have 17.8321 plus 13.2039. Now if I add these two, 17.8321 plus 13.2039 is going to give me 31.036. Now over here, I have 5.1 plus 4.37 to be done first. That's going to give me 9.47. And if I multiply that by 0.8, I'm going to get 7.576. Now plus 4.6 times 5.1, that gives me 23.46. And if I combine these two, so 7.576 plus 23.46, I'm going to end up with 31.036. So the same number on both sides of the equation. So I know my solution y equals 5.1 is correct.